Alright, moving on to problem 13. I'm going to take negative 2x squared minus 6x plus 56 and factor it. So I've got a greatest common factor of negative 2. So let's take that out, and we're left with x squared plus 3x plus 28. And I want to see if I can turn this into a couple of binomials. I know that something times something is going to equal, I wrote this down wrong, negative 28. And that same something plus something will equal 3. Needs to be two factors that are fairly close together, only 3 apart. So how about a 7 times a negative 4? That equals negative 28. And a 7 plus negative 4 equals 3. So with that, I can actually create my binomial terms. Binomial factors, I mean. So I've got an x and an x, and I've got a plus 7 and a minus 4. And we're done. Problem 13. Problem 14. Alright, we have, I need a little more space for this one, m to the 5th plus m to the 4th minus 625m minus 625. So perhaps grouping. It's 4 terms, so I can't, it's not a quadratic exactly yet. I'm going to group it. Those, and I'm, whoops, personally I'm going to rewrite that a little bit because I like this to be a plus a negative 625m. That just helps me think about it better. So, greatest common factors here is going to be m to the 4th. So that leaves an m plus 1. And greatest common factor here is going to be negative 625. So I'll take that out, leaving me an m plus 1. Now I've got these two terms. The greatest common factor in them both is that binomial, so I'll pull it out, and that leaves me with these two terms. So m to the 4th minus 625. But we're not done yet, because this is a difference of squares, isn't it? So difference of squares, we take the square root of both the terms and put them in two parentheticals, one with a plus and one with a minus. And that's the square root of 625. So we're still not done, because we still have another difference of squares here. We have an m and an m and a plus and a minus and a 5 and a 5. So I've got that factor, this factor, and these two factors. Multiply those together and I'm going to get my original expression. So I've got a m plus 1, an m squared plus 25, an m plus 5, and an m minus 5. And we're done. Now, moving on to problem 15, running out of space. Okay, 15 looks like it's not too bad. But it's a matter of remembering that we are factoring a difference of cubes, not a difference of squares, and there's a special way of doing those. I'm going to take the greatest common factor out first, because that's always the first thing I like to do. Hopefully my focus isn't too bad for you. But I still have a difference of cubes, and how do we factor a difference of cubes? Here's what we do. We have I just use this little algorithm. It's going to equal a minus b times the quantity a squared plus a times b plus b squared. And just in case you ever need to remember this, if we're doing a sum of cubes, it's similar but different, because we wind up with a cubed plus b cubed equals a plus b, a cubed minus a times b plus b cubed. Just an aside. But we're interested in this right now because we have a difference of cubes. So we have our a to the third minus b to the third. So that's going to equal, running out of room, x minus 2, because 2 is the cubic root of 8. And following our algorithm, we've got an x squared plus x times 2, so I'm going to say 2x, plus b cubed, squared, sorry. So that's going to be 2 squared, which is 4. And I took a 4 out. Don't want to lose track of that. We're done.